So students, now we'll start with a new topic, the writing numbers in the standard form. So standard form is a way of expressing the numbers in the exponential form. And it's been most or less used in the science, as you studied in the science, that for example, the distance between the earth and the sun is about this much kilometer, and the mass of the dust particle is about this much kg. So these are the problems faced by the scientists. So what the scientists have done it to express very large numbers and very small numbers. They adopted a new method where they were used to write it like this way: 1.5 into 10 raised to the power of 8 kilometers, and this particular kg as 7.63 into 10 raised to the power of minus 10 kg. Now here you have to write it down in your copy. A number can be expressed in the form a into 10 raised to the power of n, where the a should lie between 1 to 10, that means 1 is included but 10 is not included, and n is an integer, that means it can be a positive or it can be a negative. Is called a scientific notation of the number. So this complete box to be written in your classwork copy. Make it sure you definitely write it. Now come to this, here the digit a is called the coefficient, and the second number is always written in the exponential form with the base 10. Always we will be selecting here the base as 10. The standard form or the scientific notation are the one and the same thing used by the scientists, mathematicians and engineer when they are working for very large or for very small numbers. Now if you see the tips here, the scientific notation, also known as standard form or exponential notation, is a way of writing the numbers when the numbers are too large or when the numbers are too small, so that they can conveniently write the integers or in the decimal form. Now let us come to this example where we have to express this particular number in its standard form. Now how to do it? What the step 1 says, put the decimal point after the first digit from the left. That means we have to place the decimal between 6 and 1 and drop the zeros to get the numbers of the a. The coefficient in this case comes out to be 6.12, and after decimal how many digits are there? 6 digits are there. So what will be my answer? 6.12 into 10 raised to the power of 6. I suppose it's clear. Count the number of places from the decimal point to the end of the original number, and that will be n raised to the power of base. That is base 10 will be there. Now come to this example where the number is too small now. Again we have to convert them into the standard form. So what I will do, the decimal is existing here. So I will take the decimal between the first two non-zero digits to get the a, that it comes out to be 8.43, which is my a. Now how many places of decimal I have to move it from here to here? So if you count the number of digits, 1, 2, 3 and 4. So 4 places of decimal we have shifted it, and this time we are shifting toward which side? Toward the left hand side. So left hand side the result will be always negative. So the base will be having the 10, but the exponent will be a negative. So my answer comes out to be 8.43 into 10 raised to the power of minus 4. Now come to the next example, number 14, where we have to in the decimal notation we have to convert them into the whole numbers or in the decimal form. Here we are having 10 raised to the power of 5, and we know that 10 raised to the power of 5 is equals to 1 lakh. Placing this and removing the number of zeros from here. What they have done it here, you have to see how much decimal place we are having. Since we have got the 2 decimal place, so you have to remove how many zeros? 2 zeros. How many zeros you have to remove? 2 zeros you have to remove, and which comes out to be 425 into 1000, which comes out to be this much number, 4,25,000. In this case 10 raised to the power minus 6, since it's minus 6, so it will be coming in the denominator, and this time how much zeros will be removed and place the decimal sign? Since before the decimal only one digit is existing, so we'll remove 1 zero, and that much places we will continue with this number of zeros. How many zeros are left now? 1, 2, 3, 4, 5. So they have placed it 1, 2, 3 and 4, 5 zeros are there, followed by 3, 1, 7. Now in the tips, if you see here, for the solution of example number 14, it can be done by moving the decimal point 5 place to the right. Directly the a part you can see here, 5 places to the right and 6 places to the left. This decimal we have moved it to how much place? 6 places to the left. This is also one method to solve this question. Now you have to try this one in your classwork copy. These two examples, that is try it and do it in your keep it there. Now example number 15, the storage capacity of the computer hard disk is 500 GB. If the size of each document is 25 KB, how many documents can be stored in the hard disk? Given in the scientific notation, as we know, it's been given that 1 GB is equals to 10 raised to the power of 9 and 1 KB equals to 10 raised to the power of 3 bytes. Now as they have written it, so we have got 500 GB, so 500 multiplied by 10 raised to the power of 9 and 25 KB will be 25 into 10 raised to the power of 3 bytes. We have converted both these units in the same units now. Earlier they were different units were there. Now we have converted into the same units. Now you can divide the number of documents if you require it. You have to simply divide, which comes out to be equals to 20 into 10 raised to the power of 6. Since 1 0 is extra here, so we have to place it in the standard form. So it will be coming out to be 10 raised to the power of 7, because the 20 can be written as 2 into 10 raised to the power of 1, and that will get added, and this results comes out to be 10 raised to the power of